Hello everyone. Today we are going to look at amides and their preparation. So first amide. It's a organic functional group which has nitrogen. So the general formula of amide. General formula of amide is R C double bond O NH2. So when I want to write displayed formula, I'll show all the bonds. So all the bonds are shown. For example, I hope we already talked about this. R is any group, maybe alkyl or aryl group. So let me take a methyl group. This is a methyl group. So if I have this amide, the displayed formula of this amide will be showing all the bonds. This is a displayed formula of amide. What is the skeletal formula or structural formula first? Structural formula will be like RCONH2. For example, CH3CONH2. When I say skeletal formula, R double bond O NH2. In the skeletal formula, we don't show the carbon, so simply it will be black. So I'll have something like this. For example, CH3 we don't show, double bond O NH2. So this is the skeletal formula of the example I have taken. So now how to name these amides? The systematic name or IUPAC name of this amides, basically it is called as alkane amide. This alkane refers to the number of carbon atoms, including the carbon double bonded O, carbon atoms in a straight chain. Straight chain means a continuous chain. So let me take some examples. If I take CH3C double bond O NH2, it has two carbons. So ethane amide. If I take this CH3C double bond O NHCH3. Now this is a substituted amine. So the nitrogen is connected to a methyl group. So N-methyl. As usual, ethane amide, because the longest chain has two carbon. The longest chain I am talking about is, this is the longest chain. This is the longest chain. Here also this is the longest chain. So this CH3 is attached to the nitrogen. So that's why it is N-methyl ethanamide. For example, now here you have the longest chain is 3 carbon chain. So propanamide. If it is 4 carbon, butanamide, 5 carbon, pentanamide. So I can even have this. So here I am having 4 carbons, including the carbon with a double bond O. So it is butanamide. I can have this also. Now the nitrogen is connected to a 2 carbon branch, N-ethyl, and there are 3 carbons in a longest straight chain, propanamide. In all these cases, you can write like here particularly C2H5C double bond O NH2. This is propanamide only. And here also you can write C3H7C double bond O NH2. This is butanamide only. Here also I can write C2H5C double bond O NHC2H5. So this is N-ethyl propanamide. So I hope the naming is clear. Now I am moving for the preparation of amide. The preparation of amide, I am going to take only 2 reactions. Preparation of amide. The first one is acid chloride, which is treated with ammonia, concentrated ammonia. Acid chlorides are highly reactive, so at room temperature itself this reaction happens. You will get amide and hydrogen chloride. So in general, R can be any alkyl group, C double bond O Cl. This is acid chloride. Ammonia, we know NH3. This is ammonia. Now what we are going to have is, we are going to have this hydrogen chloride removed. This hydrogen chloride removed. When this hydrogen chloride is removed, so I write HCl. What is left out are C double bond O N H H. So this is amide. So in the place of R, you can have any group. I can say I am taking methyl group. So CH3 C double bond O. I would say I am having chlorine plus I am treating with the concentrated ammonia. This is the hydrogen, the blue color hydrogen is going to go with the chlorine. So what you will get is, you will get the hydrogen chloride removed. Then I am going to connect the remaining CH3 C double bond O NH2. This is actually ethanyl chloride. Ammonia. This is ethanamide. So let me take, if I want to prepare, CH3, CH2, C double bond O, NH2. I want to prepare this. I know I'll get HCl as the byproduct. So what are the acid chloride I have to take? Which acid chloride I have to take? And I know one thing, ammonia I will use. So what is that acid chloride I have to take? The chlorine is from the acid chloride. Then what is remaining? What is remaining? I'm going to write this. C double bond O, CH2, CH3. So if I know the formula, structural formula of any amide given to me, then I'll be able to identify what is that acid chloride I use to prepare amide. There is a second way of preparing amides. I can use the same acid chloride. This time, instead of ammonia, I'm going to use primary amine. This also can act as a nucleophile. It's a nucleophilic substitution reaction. I'll get substituted amide. Substituted amide in the sense, one of the hydrogens connected to nitrogen is going to get substituted by an alkyl group. So you get hydrogen chloride as the byproduct. So I know acid chloride is RC double bond O Cl. And I know primary amine. In the previous video we have seen the primary amine. So let me give the same color of hydrogen which is going to be removed. So the primary amine will have NH2 group with an alkyl group. Can be a different alkyl group. So now I know I'm going to get this small molecule out, HCl. Then I'm going to connect the remaining R, C double bond O, then this side a nitrogen, hydrogen, then R dash. The R and R dash can be anything, any alkyl group for that matter. Even it can be an aryl group. So I'll take an example like R is replaced by a methyl group. So we know that it is ethanyl chloride. And R dash is replaced by, let me say, an ethyl group. Even you can have methyl group, it doesn't matter. I'm having ethyl group. So what I will get is, I'm going to get HCl. I just use the same color code so that there will be no confusion. Then I connect the remaining in yellow color, C double bond O, then NH. I'm not changing the order. Please, you have to follow the same order. We don't change the bonds. So this is N-ethyl ethane amide. As usual, this is ethanyl chloride. So today what we learned is, we learned how amide group look like, how to write its structural displayed skeletal formulas, how to name them systematically, how to prepare amides. We used acid chloride as the starting materials. From acid chloride, using ammonia, you will get simple amide. Using primary amine, you will get substituted amide. I hope this part is clear. I'll continue with the properties of amides in the next video. Thank you for watching.